You know what I love a bit of? I love a bit of cream soda. I love a bit of cream soda. It's like you're drinking a freaking vanilla ice cream and you ain't going to get fat from it. Well, you might get a bit fat from it. This is meant to be a sugar-free one, but I didn't even realise. No artificial flavours or colours. Sugar-free creaming soda. It's fucking creaming good. Give me that cream soda. Look, also, something that I need to get for my workshop. Massive deal. No, this is a proper solder sucker. So the one that I have, that I've been using for years and years and years is... So yeah, just your basic like 99 cents, 99p from eBay job. And the problem with this is that the mechanism that holds the plunger down, it wears away over time and it becomes rounded off. And so it doesn't always stay held in. It just, without you even pressing the button, it just knocks itself back out. And it knocks itself back out by just literally just touching the button the tiniest bit. Very annoying. And it's okay, but it's not that powerful either. It's made way better by adding the silicon tip. That is a game changer for solder suckers. Now, Brad has fucking Mr. Industrial solder sucker right here that we've put the silicon tip on yesterday, and this is the real deal. Okay, we're almost ready to go. We've got the RTA mic set up, so this should sound a lot nicer to you now than just the camera's built-in mic. Went for a cheeky peanut slab. I do quite like peanuts. I do quite like nutty chocolate. Yes, so with an amplifier like this, we already have most of the stuff taken off the board. Brad has gone ahead and removed all of the output FETs so that we are just left with the pads here. He's also removed the driver board. It's now just, it's not soldered in, it's wobbling in the holes here. So the driver board, what we can do is we can actually power the amplifier up in this current state. I'm going to put some pressure on the driver board here to make sure that all the pins make the contact, some hard pressure. I do this as well. You can't do this, never do this when there's FETs in the board. You can only do this when there are no FETs in the board. It's perfectly safe. As long as you be careful not to touch with your fingers any of these little metal blobs on the back, because they can sometimes have very high voltage. So just place your fingers where there aren't any of those. Push it one way or the other to push it on the pads, and then we're going to fire the amplifier up, and we want to make sure that there are voltages where they are supposed to be. Now, if you watch my videos, you already know how the high and low side rail voltages work and where they're supposed to be. If you don't, I will cover it very, very quickly here for you now. So I'm just going to go ahead and turn the power supply on. He says, what the fuck? Oh man. That's a very poor connection on the mains there. Jesus, right, okay, a few things we're working with here. So if we take a look at the output FET locations, there are some that are high and some that are low side. You'll get to know what this means as you start getting more into amplifier repair. Low side MOSFET pad locations need to have low voltage rail on pins 1 and 3. So that will be like the gate here, pin 1, and the source here, pin 3. So they need to have the negative rail voltage present on them. So minus 70 volts, minus 100 volts, however big your amplifier is. There should be nothing whatsoever on the middle pin, the middle pad of the low side. So low side is negative, negative, nothing. The high side ones have the exact opposite. So we should have nothing on number 1, nothing on number 3, but we should have the positive rail on number 2. So you don't have to have the driver board in for this test. You can remove the driver board entirely and the rail voltages will be apparent where they're supposed to be, and that shows you that things are ready to move forward. If you have a dead drive chip, a drive IC, IRS21844S, what sometimes happens is it actually leaks negative voltage onto the high side gate where they're supposed to be 0, and that is a good indication that the chip is dead and shorted. So what I'm going to go ahead and do is probe all these different banks to work out if the voltage is where it's supposed to be and if any of these drive ICs are dead. So let's start off with number 1 over here. Let's give the remote a little bit of a push, get the voltage climbing here. So it looks like this one is a positive, it's a high side. So you see that is the positive rail starting to build on pin number 2, the center pin. Pin number 1 and pin number 3 should have absolutely nothing on them, which is correct. They have absolutely nothing on them. So high sides are generally, with these type of amplifiers, on opposite sides to each other. So you have a high side over here, which is like 3 FETs, and then you have 3 FETs of low, 3 FETs of low, and then 3 FETs of high. So this is the other high side. So let's have a look. We have positive rail on number 2, nothing on 1, nothing on 3. Note that I'm actually, the amplifier's off. So all I've done is I've just pulsed the remote just for a brief second there, just to build the rails a little bit so we can see what's going on the screen. Let's check the other side of the amplifier. So we have another high side over here that has positive rail on 2, nothing on 1 and 3, and the other side of high side is correct. Now the low side should have, like I said, on pin number 1 and pin number 3, it should have negative rail voltage. So let's have a look. Negative rail voltage on 1, negative rail voltage on 3, and nothing on number 2. So yeah, this all checks out just fine. So now what I'm going to go ahead and do is power the amplifier up fully, let the rail voltage build to its top. So because I'm pushing on the driver board, so with the driver board in, the driver board will try to drive the FETs. You only get a square wave on the low side of FET locations when there aren't any FETs in the board. So by having the driver board in like this, I'm going to push to make a contact, and I'm going to go ahead and probe one of, just any random one over here. I'm going to go ahead and probe this low side gate. What I should see is the rail voltage will start to sink down to negative rail. It will get to a point, it will get to a tipping point where the voltage is high enough for this drive circuit to activate. When it activates, I should hopefully see a small square wave appear on the multimeter screen, on the oscilloscope screen. Let's see if that is the case. Alright, so the amp's actually doing something strange. It's going in and out of protection. We have disabled the 9-volt protection, so it's not due to low voltage. It will try and come on like this. Usually the amplifier will only protect in this manner if it detects DC on the speaker terminal. So what I'm going to go ahead and do now is I'm going to go and probe one of the outputs here. I'm going to go ahead and probe the low side drain. On the low side drain we shouldn't have anything whatsoever. So let's see if there's any DC that appears on the low side drain as this is trying to fire up. No, that looks alright. Let's check this other side. No, it's just clicking into protection. Let's try, so let's have a look. I'm going to probe the low side drive here. It doesn't look like we're getting any square waves. No, so it's just going in and out of protection mode. So what I'm going to go ahead and do now is remove the output driver card, and that should allow the amplifier to turn on without any problems, because there would be no other reason for this to be going into protect like that. Right, so just lifted the driver board out. So this has no reason to be in protect anymore. There aren't any voltages where there shouldn't be. The only thing that would cause it to protect really is either the driver board here. Sometimes there's a muting transistor which is just here by the driver board that fails, shorts out, and it causes protection. But it's not very common. It's pretty rare. So let's see what happens now if I turn it on without the driver board. Yeah, okay, there we go. So we have full operation now. We don't have any protection. It's coming on and not flicking in and out of protection mode. So there's something going on with the driver board or the muting transistor, because the muting transistor, if it is bad, it won't actually cause the amplifier to go into protection without the driver board being there, I believe. Cool, so the voltage in the capacitors here has sunk back down to 0, so the amplifier is safe to work on again. Now I have a couple of initial ideas as to why putting the driver board in is causing this to go into protection. Idea number 1 is a really weird one, but it's an issue that I've experienced back at home. Now, Brad used some solder flux when he was removing the driver board here. It's very sticky. There's loads and loads of residue solder flux between these pins. Now, the solder flux usually it shouldn't be conductive. However, from my experience, I've noticed that if solder flux is left on these boards, on these pins, sometimes voltage can leak between the pins and cause all sorts of strange, weird and wacky issues. One of those most likely being protection. So I'm going to go ahead and clean it up with some isopropyl alcohol. You can see here on the driver board as well, there is a lot of, let's get that focused. Yeah, there's a lot of like kind of sticky flux residue, some pulled veers as well. I wouldn't have thought that would be causing the problem. as I'm pushing quite hard on it, so I imagine they're making a connection, but I'm going to clean it all up first. And after I've cleaned it up, before I try and power it up again, I'm just going to take my multimeter. I'm going to read across this transistor here. Now this Q52, that is the muting transistor. So if there is any issues that the amplifier detects on the output circuit or the drive circuit, then this transistor is responsible for sending the amplifier into protection mode. So sometimes these short out and they cause the amp to protect. So I'm going to go ahead and make sure that that isn't shorted. It's quite a common thing to happen. Right, so let's go ahead and check that muting transistor. So we're going to go ahead and put our multimeter to diode beep mode so we can hear for shorts. Yeah, that checks out okay. So it's probably not not the muting transistor that's the problem here. So it's either the fact that there was some conductive flux sitting there, or it's actually that there's a problem on the driver board. These drive ICs could probably do with changing out anyway. I've got a ton of spare ones, so I'll probably go ahead and do that. I'm just going to go ahead and real quick test a couple of the things on the driver board here that sometimes die. Things to look out for that commonly fail on these driver boards are these bootstrap diodes, I believe these are. Yeah, these are the bootstrap diodes. These can short out quite easily. Also, these bootstrap capacitors next to them, check that out as well. Now, these drive ICs, there are ways to check with a multimeter whether these are completely damaged and blown up inside, but often they just get damaged in a very subtle way that only really shows when you try and run them. So if the amplifier is experiencing problems like this one, it's just going into protect, and cleaning that up doesn't make any difference. First thing I'm going to go ahead and do is check for shorts on these diodes and capacitors and change all 4 drive ICs. When I'm changing all 4 of these drive ICs, what I'll actually probably do as a good test, just to see, make sure that I'm not sort of going around in circles here, is once I've removed all 4 of these chips, I will put the board back in the main board with the drive ICs off and make sure it doesn't protect, because that will then tell me if the amplifier still protects with the drive ICs removed, then it's not an issue with the drive ICs themselves. It will be something else on the driver board. Cool, let's whack her back in, and I don't think this is going to have made any difference. I think it's probably the drive ICs, but just from past experience, you've got to start from the simplest thing. You've got to start right at the bottom, because sometimes I dive right in and I'm like, oh, it's going to be this, it's going to be this, like the complicated version, and it turns out to be the really fucking weird simple version that's actually the problem, and it's a waste of time. So yeah, let's go ahead and probe the low side drive once more, and let's give her some power. Nope. So we are going into protect, and actually this time on the scope here you can actually see a little bit more. Oh no, interesting. So it actually is building a square wave. This scope is just very not easy to see that. So there is a square wave being built, but it's just very fucking hard to see. So yeah. Okay. So noisy. Right, so I'm going to go ahead and actually check that out on all of those low side banks, because if there's one drive IC that's bad and it's not building a square wave, it's just going DC, then that might be why it's deciding to protect. So that is bank number 1 on the low side. So let's check bank number 2, which is just over here. Yeah, that's trying to build a square wave. Let's go for number 3 over this side. Okay, yeah, that's trying to build a square wave. And let's go for number 4 over this side. Yeah, so it looks like that all 4 low side banks are actually very, very briefly building a drive wave. But as soon as the drive wave is built, and as soon as the amplifier realizes that there are no effects in the board, it protects. This is very uncommon. There is something we can do to disable the protection circuit to allow this thing to stay on with no effects in, so I can check all the drive waves. What we can do is take a look over here. So this here is the power supply driver board. There's a chip on this board called a KA7500C. Sometimes it's also called a TL494, but it's all the same chip. Now, pin number 1, 2, 15 and 16 are input pins for comparators, and they listen to different voltages and signals going on the amplifier to decide whether it's working fine or whether it needs to go into protect. When it decides it needs to go into protect, pin number 3 will go from 0 volts to about 5 volts, and that's how you know it's in protect. So we can disable the protection circuit by grounding pin 3, preventing the amplifier from being in protect mode. So obviously that's on the driver board there, but rather than, let's try and have a think about this. It's probably going to be, I'm going to say there's probably going to be one of these pins on the actual driver board itself that we can ground out to prevent it going into protection, rather than having to do some funky tiny baby soldering on the surface mount chip there. So I'm going to go ahead and just see now. I'm going to flip the board over and try and work out which one of those pins is actually causing the amplifier to protect. Right, so there's two pins on here that appear to be doing something when it goes into protection. So the first pin that reacts is this, I'm going to call this pin number 2, down from the top here. So if we probe that and try and power the amplifier up, on the scope here we can see that it jumps up when the protection kicks in. However, it's very, very sudden, and it is exactly perfectly in sync with the protection LED. So I believe that one is the protection LED output pin, and I can confirm that by following it with my multimeter. The other pin that does something as it goes into protect is this last pin here, pin number whatever the fuck, however many that is. If we probe that and try and power the amplifier up, you can see that as we power the amplifier up, it raises slowly and then goes back down again. And it seems that when it gets to a certain height, the amplifier protects and it sinks back down to 0. So what I'm going to do to confirm that is I'm actually going to go ahead and pull the driver board out in a sec once the voltage has sunk down a little bit again, and then probe this last pin one more time with the amplifier not going into protection and see if it stays at 0 volts. If it stays at 0 volts and the amplifier doesn't go into protect, obviously without the driver board in, then I will trace back where this is going to see where that kind of leaky voltage is rising from. Driver board removed. Let's see if this pin still rises when it's not in protect. Nope. It stays down at 0. So I believe that is what's causing the amp to protect. So the amp could actually be fine. It could just be protecting because it's got some interesting circuit that others don't seem to have that protects when it doesn't detect any MOSFETs. But I don't want that to happen, so I'm going to go ahead and ground this pin so that the amplifier doesn't protect when we don't have any FETs in. So I want to check the drive waves properly. Right, let's see where's the nearest ground point to this. So rather than having to go all the way over to a main ground, there'll be another ground around here somewhere that we can just tie onto. So yeah, provided my calculations are correct, this should now fire up and stay operational without the MOSFETs in, and we should be able to see the drive wave nice and clear on the scope screen. So let's go ahead, probe the low side drive once more. We're going to go on to AC coupling, so we can zoom into the drive wave, go down to 5 volts divide, and yeah, we want about 20 US. Turn the power supply back on. There we go. Success! So that was the pin triggering protection. Perfect. So this is not the easiest scope to see that drive wave on, I have to say. So I'm just going to show you what that looks like. Yeah, it's so noisy. I'm going to try and clean that up and get it zoomed in a bit. Yeah, right, so that all looks good. That does all look fine. So yeah, we haven't actually had to change anything yet. The low side drive does look alright. So what I'm going to go ahead and do now is I'm going to go ahead and whack some random FETs in. Right, so while that rail voltage sinks back down to 0, so I can whack some FETs in it. Let's have a drink. I'm fucking thirsty. You get real thirsty out here because it's kind of humid, so you're always kind of a bit moist, a bit sweating a little bit. Oh damn, that's fucking good! What the hell is this? Mildura? How do you pronounce that shit? Orange and passion fruit. I don't usually like passion fruit things because it's quite bitter. It's quite a kind of soury taste, but this is, it's a bit like squash. It has a kind of consistency a bit like squash. It's kind of a watery, kind of subtle kind of juice. Really tasty actually, really refreshing out here. Let's hit up a snack as well. Got the munchies. I am going to give, do I try these cheese supreme? Or do I really do quite like pretzels. These make mini wheat pretzels. What are these? Are these just salted? Oh, you can hear it, look. You can hear the salt in there, Jesus. Yeah, fuck, I'm going to crack open the pretzels. Going to fire up the power supply, got 9.5 volts on there, and we've got the two traces on the scope which you'll see rise in just a sec. So we've got the high voltage rail starting to rise, and now hopefully we get some square waves on the output, on the drain of the low side. And let's see if it survives and doesn't explode. Wicked, right, that's really interesting. So the amplifier appears to be fine. The rail voltage is still there, which means that we don't have any shorted FETs. If we did have a shorted FET, then that would be down at ground. So it appears that this board, this amplifier here, I've removed the patch lead. See? I've removed the patch lead from this. So the issue that it was going into protection before, I thought was because it detected it didn't have any FETs in the board. However, that appears to not be the case, because it's still going into protection when you try and fire it up. So I'm going to put my patch lead back to disable the protection circuit, see if the amplifier comes on and stays on and there's no problems with it. If it does and it's fine, then this has a fault with the protection circuit somewhere, which is causing it to come on. So what I'm going to do is I'm just going to wait for the rail voltage to sink back down to 0 again. Fucking hate waiting for this. And then I'm going to reinstall my patch lead, and yeah, that will force it to stay on, and it should work fine. Then we can work backwards, and we can work out what the problem is with the protection circuit. Alright, so this is the second try now that I've reinstalled the patch cable that disables the protection circuit. Let's hope it stays on. Ta-da! Perfect. So that is exactly what we want to see. You want to see the rail voltage staying where it is, and a nice big drive on the drain of the low side FET. So yeah, awesome. I'm going to run that for a bit longer just to make sure that none of the FETs are getting hot, to make sure that it's balanced correctly. And then once the rail voltage sinks back down again, I will start looking into where the problem with the protection circuit is. Okay, so in order to find this protection circuit fault, we know that it is coming from the output section. We know that the output section protect trigger is the thing that's causing this problem, because when we remove the output driver card, the protection issue goes away. So it's something to do with the protection trigger from there, and it sends it to the driver board for the power supply, telling it to turn off, so the amplifier basically shuts down. So what we need to do is we need to go ahead and flip this over. I'm going to just break this apart real quick, and I'm going to follow the trace. Oops, shit. Follow the trace and find out where it goes. So because this amp breaks in half, it actually makes it a little bit easier to follow the trace, because we know that the protection trigger will be being sent down through these headers. One of these, yeah, our patch cable. So at the moment it's grounded. That's not going to be useful, because anything that we touch that we try and read is just going to show us ground. So I need to remove this patch lead first in order to be able to trace it properly. So I've been doing some tracing of that protect signal that's coming in here. It originates from one of these pins. This third pin here goes through there, goes directly to the driver board. You then follow it this way, and it is connected directly to this pin here on the driver board. And this pin here goes to, if we focus that up, it goes to this diode here, and then it goes through a 4.7 ohm resistor, and then to this 2D transistor. So I'm willing to bet that either this diode or this transistor is faulty. Interestingly enough, I have one of these driver boards spare. Okay, and if I put the multimeter onto diode setting and I read this diode, across one way it reads about 540, and the other way it reads infinite. However, when I read this one way round it reads about 256, the other way about 331. This could, however, be because this is in the board, it's mounted to the main circuit. It's difficult to tell. I could check all of the other Sundown 7Ks and see if they are exhibiting the same problem. If they're not, if they come on and work fine, then I can obviously check that diode in the board as well and see what that's doing. But yeah, I'm wanting to bet that it's either something to do with this diode or this transistor here. So this is amp number 2, and I haven't actually tested this board yet. I'm just about to in a moment. I haven't tested this board without our patch lead, so I don't know if this one also does the same protect thing, on off on off. However, this diode here on this one way round it reads 480, the other way reads 256. This one, however, reads 360 something one way round and about 240 the other way round, so there is a difference there. So next thing I'm going to do is plug this one in to the power supply board that I've been using without the patch lead and see if the protection thing still happens. I've actually just realised, and I just spotted this, the 4R70 resistors here look a bit damaged, and I think these got damaged somehow. Whatever happened in the vehicle somehow drew current through these resistors, and these are failed, which is why the amplifiers are going into protect all the time. Really weird. I've never seen that before. Yeah, look, right, so this is the 4R70 on my spare board, and this reads 4.7 ohms. It's going to show as 5 because I got it on diode mode, so it's not that accurate. But yeah, that's supposed to read around 4.5 ohms because that's a 4.5 ohm resistor. However, this one as well is completely open. It doesn't read anything. So I think that is our problem. So right now I'm just replacing that resistor carefully with the driver board still attached, because like I said, I don't want to remove it again if I can avoid it. So just doing some very delicate work here with the small tip soldering iron and the heat gun. So I'll just refresh the solder pads there on that resistor. I've got my spare resistor from the spare driver card. Good job I brought these. Don't think I have any other. I've got some 4R7 resistors at home, but to be perfectly honest with you, I did not think I would need those, so I didn't bring them with me. I imagine that they'll be available at the shop. Brad's got a shop nearby that sells this sort of stuff. I'm just going to whack this one on from my donor board just to prove a theory. So now let's see if it turns on without the patch lead. So back in here we go. Moment of truth. Has that fixed the strange protection circuit fault? Fuck! It hasn't. Okay. But the fact that that resistor was blown means something. Bugger. But we're in the right area. We are making some freaking progress. I found another dead component on the driver board. You know that 4.7 ohm resistor that was open? The diode underneath it is also bad. It's also damaged on all 4 of these amplifiers. Replacing the diode doesn't bring it out of protect, but it stops it protect looping. So replacing the diode for a decent working part gets out of the protection loop, and it now just goes into protection once and stays there. Now fortunately, as you know, I brought a whole bunch of spare driver boards with me that are functional, but we're just missing a load of components. So what I did is I built up a fresh driver card here that I know works, you know, in the sense of all the PWM generation circuit and all the dead time and everything else like that. So what I did is I took the IRS21844S off of the driver card, which appears to be causing the protect, and I dropped them onto my fresh new rebuilt driver card that I have assembled just now with all loads of spare parts from all the other driver cards. And lo and fucking behold, when you power the baby up, it comes straight on and doesn't go into protect. We have nice drive waves there on the scope screen. So that then proves that whatever the issue is that's causing our protection is on the original driver card. So it's a driver card fault, and we can prove that even more so by taking the original driver card for this amplifier with only the IRS21844S chips removed. Everything else is still on here. I've obviously replaced the 4R7 and I've replaced the diode, and just by dropping this in without even any drive chips on there and trying to power her up, she goes straight into protection. So it is the freaking driver board. Whereabouts on the driver board, however, is we are yet to find out. Wherever the issue lies, it's somewhere on this driver card, And rather than trying to find the issue, it might actually be quicker. It's going to take a while. This is not a quick process by any means, you know, whichever way you look at it. But the quickest way might actually just be to take the driver card that's causing the protect, this one here, remove this baby from the board, try not to get electrocuted with, it's only 48 volts, it's not too bad. So take this bad driver card out, and take like one of the other spare driver cards that I've got laying around, and literally just swap parts, try it again. Doesn't work, swap another part, try it again, swap another part, try it again. Just keep swapping parts until I swap a bit and it starts to work. And then I will know that that is the faulty component. It's a lengthy process, but I think that's where it's at right now. Yeah, check this shit out. So this, I don't know if you get this elsewhere in the world. I mean, you probably do, but I've not seen it before. This is like fat off sausage, and it's got cheese inside, and so you cook it up, cheese gets melted, it's nice and fat. I'm probably gonna try to think whether to slice it in half long ways or just do it in half. So finally got round to finding the issue, and yes, as we thought earlier, it was actually on the driver board. So what had happened, and I'm actually just going to go ahead, just quickly, you can see here this amplifier here. So this one, we didn't take it out of the case at all. I didn't remove it from the case because the issue was just on the driver board. So this one was still in its case. All the FETs were fine, didn't have any blown FETs whatsoever. This is a really strange issue. I've never seen this before. Something fucking weird happened. I couldn't tell you what, but I believe something funky came in through the RCAs, because some of these amps were slaved, and when the slave input RCA port is tied directly to the driver board, and the driver board got fired. I don't fucking know what happened, but we fixed it anyway. So this amp works perfectly fine. I've made the changes that I believe that I discovered were things that were dead, and I've done that to 3 of these amplifiers now, and they're all now fully functional. So we've just got the 4th one to do. As you can see here on the scope, we've got a nice beautiful square wave there. We're running this at 14.3 volts, so a high voltage test, and you can see the top rail there. If we click on measure, we're actually doing, what's this, peak to peak, 366 volts peak to peak. So yeah, it's a very happy bunny. So with all the tracing that we did earlier with the signal that was being sent to the power supply driver board to shut down, we discovered that it was this pin here that was responsible for sending that signal. We traced it on back the driver board. It went to this diode, which I read was actually very badly damaged. It was reading both directions and strange numbers. It should only read one direction, being a diode, and the other direction should be pretty much open. It shouldn't show a reading. Then after the diode, there was a 4.7 ohm resistor, which on all of these amplifiers was wide open. It had blown as like a crack down the middle, you could see visibly. And that had also taken out the transistor, which was tied to the 4R7, which is this little 2D transistor here. So by replacing 1, 2, 3 components on the driver board, these amplifiers are back up and running. Whew. So that is a long ass day of working. So pretty much been in here since like 8 or 9 in the morning. It's now like 9 or 10 in the evening. So but I wanted to spend as much time as I could today finding the common problem with these 4 amplifiers, so that tomorrow can just be taken up with reassembling them, fitting the parts, and we can get any new parts we need if need be. I think I'm going to need one of those diodes. I'm not quite sure what spec they are, so I need to check that out on Perry's guide. And I'm going to need another 4R7 resistor. I don't think I brought any of those with me. So yeah, it's good that I got that all done today, figured out what the issue was, and yeah, then I can start giving you some demo videos of Brad's crazy Vito with all 4 of these amplifiers in it. And like, I got a demo of it with I got a demo of it with one 10k amplifier, and this has got the 4 7500s, and apparently, like, you know, Brad's like rolling around with the 10k in it going, oh, this sounds really quiet, and I'm like, fuck it out, bloody, what the fuck. So I'm not sure I'm quite prepared for the 4 amps, but we'll see how that goes. Alright, so that's 1 amp, fully reassembled, all repaired. So now I'm going to go ahead and do the same for the others, and these were some of the ones that had some blown FETs. So what Brad's done is he's removed all the output FETs. We've got a whole big pile of them here. They're all sort of different batches. They're all similar. You've got one G37AA, one G47AB, some very different batches here. So what I'm going to do is these FETs were run in the original amplifier, and they were running very, very hot, and so their RDS values may have changed as a result of excessive heat on the MOSFETs. So I'm going to go ahead and take my transistor tester and say, because these are really freaking expensive here, right? So if we're to load up 2 of these Sundown 7500Ds with brand new FETs is going to be pretty expensive. So Brad has said that he's willing to reuse the ones from before that survived. I've got some FETs with me as well that just by chance happen to be the same freaking batches as the ones that are in this, because they're all made in the same fucking place at the same time anyway, so yeah, it's all good. So I'm going to load up these with some of mine, and hopefully we've got enough FETs that still are good to load up 2 of these amplifiers fully loaded, and I'm going to make sure that the RDS, the VT and the CG all match as close as possible in parallel banks. Okay, I have grouped these FETs according to mostly RDS. Their VT is all pretty much the same, CG is all pretty much the same. So they all turn on and turn off at about the same sort of time, no problems there. However, the RDS is varied a fair bit between some of these different FETs. As you well know, electricity and current favours the path of least resistance. Therefore, any FETs that have a super low internal resistance compared to FETs that have a higher one, the current will favour the FET with the low resistance. Therefore, that will work harder, and that may blow if it's one of the only FETs that's actually passing any current. So these ones down here, these all have an RDS between 0.5 and 0.8 of an ohm. That's not the real RDS because there is test lead resistance to take into account. Obviously, if you look at the spec sheet, the RDS is way lower. However, I'm going by the numbers reading on the tester over here. They're consistent between FETs, and obviously with test lead resistance, that's fine. I can still work out which ones are lower and which ones are higher. So on the meter, these read between 0.5 and 0.8. These ones read 1.1. These ones read 1.3. These ones read between 1.4 and 1.5 over here. These ones read 1.7, so I'm not going to use those ones. Now, these are all the same batch. This is what's really interesting. So these are 1G37AA. These are 1G37AA. These are 1G37AA. However, we've got a difference between 0.5 ohm and 1.5 ohm. That's a whole ohm different. And if you ran those together, the ones at 0.5 ohm would be doing most of the power, and the ones at 1.5 ohm wouldn't really be doing much at all in parallel with these ones. So I've got to take that into account when I fit them into the amplifier. These ones over here are 47 batch. These are 1F, 47AF, and then we've got a 1G stuck in there somewhere as well, but it has the same spec, so you can use it in parallel with these. I then have bought some of my own FETs. These are a BS, they're a 38BS batch. These marry up nicely with the specs of these lower 37s, and then I've bought some of my own 1G47 batch, which marry up nicely with these ones. So I think I've got enough FETs here to reload 2 of these amplifiers. I'm going to count them up in a moment. I'm going to fit them in and see what happens. So, it's the moment of truth. Will these things work? So I've fitted all the FETs into these boards that had blown FETs originally. Now the FETs that I've used were the ones that came from the amplifiers that did have blown brothers in the board. So I'm not massively confident that these are going to survive. I think we're going to get some explosions here, just purely from experience. You know, the FETs in here were next to FETs that died, so all the FETs were subjected to whatever it was that caused the ones next to them to die. So I've got a feeling that these may be internally damaged, just in a way that we can't see on the meter or by testing them here. So the only way to know for sure is to run the amplifier. I'm going to start off with the voltage down at 9 volts. Very, very safe, low rail voltages, low stress for the FETs. If it's happy at 9 volts, and if I don't see any FETs heating up on my thermal imaging camera, then I'll slowly start cranking up the voltage to 14.4, and if they stay on and don't get hot at 14.4, then I think we were in luck. Whew. So without further ado, got the scope ready, got the power supply on 9 volts. I'm going to cover my ears and my eyes just because I fucking hate this bit. And, alright. Let's go, see what we get. Thermal imaging camera on. Power supply active. Alright, happy days. We have output switching. And by the looks of it, we have... this scope does not stay still, I don't get it. Anyway, we have on the power supply 4.2 amps of current draw. You can't see that over the exact screen. But yeah, these amplifiers at 9 volts draw about 4.12 amps, which is about right. That's where the other ones were at. Now, if I take a sneaky peek down my thermal imaging camera at the board, let's see, do we have any FETs heating up? Fantastic. No, they're all staying dead cold. If there was a problem, they'd already be heating up. Fucking happy days. Awesome stuff. Right, okay. That's all good. But now comes the fucking scary part that I really hate. Now comes the 12 volt and the 14 volt test. I really fucking hate doing this bit. Because this is the bit where they explode. Okay. So, power supply. Let's crank this up. Baby. I'm gonna go straight to 14 volt. I'm not gonna fanny around with 12. Let's go straight to 14 and watch what happens. This time I'm really fucking covering my face. Awesome! Fucking wicked! See, did any of them get hot? Nope, stone cold that side. Stone cold this side. Fucking wicked! Yes! Brilliant! Awesome! Obviously this needs endurance testing, but this is a really good sign. At 14 volts, all the FETs are staying cold with, you know, if there was a problem, that sort of 5-10 seconds of operation would raise the heat of the FETs by, you know, 3 or 4 degrees, and it would show up on the thermal imaging camera. But they are all exactly the same temperature, so I am really, really excited that this is going to be a successful repair. So this is exact same. I've got the other board here, so what I'm going to do now is wait for the rail voltage to sink back down and plug this board in and make sure that this is also just as happy. If it is, then that will be 3 out of 4 amplifiers fully repaired, and the 4th amplifier doesn't have any blown FETs, so it should just be the same driver board power supply protection circuit repair that we've been doing on the others, and that should then get that one up and running as well, and then we'll have all 4 ready to go, and we're going to wire them up into Brad's Vito, and I'm going to get the demo of my fucking life. Alright, second board going in now. So we are looking for nice drive waves, and more importantly, we're looking for 4.2 amps worth of current draw on the power supply from this at 9 volts. So I'm just going to have to recalibrate this down to 9. Put this on the low side. Okay, thermal imager. Let's go. Oh hey, this one seems even better. We only got 4.07 amps worth of current draw. There will be slight variances between these, of course, like so that's a difference of 0.8 amps roughly between these 2 amps. So yeah, just going to have a quick check with the old thermal imager. If it was heating any of the FETs, the current draw would obviously be higher because in order for heat to be generated, extra power is required. So this all looks very, very nice on the 9 volt test. So let's crank it up once more to the good old cheeky 14.4 volt test. Now it could still die at this point, because if any of the FETs have been weakened and have like a dent in the silicon in the die, then the high voltage will arc between the layers, and it'll work fine at 9 volts, but 14 it won't. So let's crank it back up, see what happens. No, that seems good. 6.3 amps worth of current draw, 14.4 volts, nice looking square waves. Yeah, that's pretty fucking tasty. And let's check for heat after that small stint of 14 volts. Nice chilly willy cold FETs on a nice hot summer's day, that's what I like to see. Yeah, fucking awesome. So that's the 2 boards that had the bad FETs replaced and up and running. We're going to do some endurance testing, and then we're going to slam them back into the Vito. I'm so excited for that. That's 3 out of 4 amps repaired. There's 1 more to go, and that is this one. So this is the 4th and last amplifier that requires repair before the weekend. Like I said, there's some other bits and pieces here that we can do, but this is the last important one. So, Sundown 7500D again. Now this probably has the same issue as the others, but just to confirm that, I'm going to plug the remote in here and see if this is doing the exact same thing as the other 3 that we had. So, and that issue was protection was just flicking on and off, in and out of protection, but it had no dead FETs or anything like that. So I'm just going to go ahead and turn the voltage back down to a sensible level. That'll do. We're going to take our scope probe here, turn channel 2 off from earlier. Let's have a look and make sure the rail voltages are building correctly. That will tell us whether there's a short on the output section or not. So we've got positive rail building there, that's fine. Wow, that is a slow refresh. And let's have a look on here. Positive, yeah, there shouldn't be anything over here, that's correct. Yeah, so that looks like it's all good. So there's no shorted FETs, otherwise that wouldn't be happening. So let's go ahead and try and power her up and see what actually happens. Yeah, same as before. So I'm not sure if you guys can see that there. But we've got the amplifier going in and out of protect, blue, red, blue, red, blue, red, like this. That's the exact same fault as all the others. So let's have a look at the driver board and see whether there's any physical signs of damage like there was. So let's have a look then. Aha, yeah, look at that. So that 4R7 resistor is definitely gone. And by experience of the other ones, D2, that diode will be dead as well Q4, that 2D transistor there. So I'm going to go ahead and just quickly replace 1, 2, 3 components there and see if it comes back to life. It's very, very lucky that I brought with me all of these spare driver boards, because these have been invaluable in getting these things working. So I don't actually know what value that diode is, because I've never had to replace it before, and it's not marked. It's such a small diode that it doesn't actually have any markings on it. So I would need the schematic for these, which I don't have with me. It's on Perry's guide. I don't have that with me. But what I've been able to do is just steal the diode from these spare driver boards that I've had. As you can see, it's all missing, as is the 4R7. So now I only brought 3 of these with me. The 4th one is a different type of driver board. However, it has the same protection circuit, just in a different location. See that up here? Got D2, that's the diode. You've got the 4R7 next to it, and then the 2D is just there. So it's the same protection circuit, just a slightly different layout of the driver board, and you've only got 2 drive RCs rather than 4. So that's my 4th diode that I'm going to steal, and then the 4R7, and then I've got loads of spare 2D transistors, so that's easy goings. Let's see if that can make it work. This is not the easiest shit to do with the phone in the way, but we'll give it a go. So now I've removed those, I need to refresh those solder pads. Cool, cool. Now let's take the parts off the other board. Let's do that real quick. Okay, new diode going on. Now the way that I do this is I get it just attached, just a tiny bit on one of these. And then once it's like attached to just the edge, I can remove the tweezers. This is really annoying with the phone in the way, for sure. I think I'm going to have to move the phone out of the way. I don't think I can show you this, guys, sorry. And make sure the diode is around the correct orientation. So what I just like sort of solder one edge of it just to the pad, just so that it's on there. The other side doesn't have to be soldered just yet. Then once one side's on, I can remove the tweezers and just let the gravity do its work and let the solder pull it in. It's a little bit tricky, but it's much quicker than taking the whole amp out the case, desoldering and soldering the driver board and doing it that way. This is much quicker and also quite effective. There we are. So yeah, not the prettiest job in the world, but not bad for a sort of side-angled, weird, on-the-piss replacement of parts. So let's give this a power up now one last time and see if that brings it to life. So amplifier number 4, will it work? Rail voltage builds. Yeah! Fucking woo-woo! Awesome stuff! So yeah, just those 3 tiny little components were causing a protect cycle. And now the thing works perfectly fine. Happy days! Time to get the other 2 back in the case, and then we can put them down to one side, ready for Brad to reinstall into the Vito. Yeah! 1, 2, 3, 4. 4 funcionaba! Yes! So that is all 4 Sundown 7500Ds up and running. 2 of them had MOSFET and drive issues, and well, all 4 of them had protection circuit issues, but in addition to that, 2 of them had the drive and MOSFET issues. So those are all up and running now. Just gotta wait for Brad to come back, and then we're gonna load them in the Vito, and I'm gonna probably get the demo of my freaking life. So that's about it as far as what I was brought to Australia for. However, there are plenty more awesome videos coming your way of other adventures that I've got going on in Australia. For example, I'm going to teach Brad how to fix the Zen on 8.5Ks. So that will be a video where I'm with the camera over his shoulder telling him what to do. So you can see, like, if you were going to fix these things, how I would sort of mentor you or tutor you to repair these things. So that will be a really cool video. And also I'm going to do some taste testing of some weird Australian food and sweets and savoury snacks. That'll be quite funny as well. I might do a taste test while getting a demo, see if I can like stomach tasting some weird shit while I'm like 160 dBs worth of bass. That'd be quite funny. But yeah, smash the subscribe button, whack the bell with your bell, and fucking stay tuned for some good content coming your way. Till next time.